Every game developer has that one game they've always dreamed of making. This is mine. Hey, I'm BK. I've been doing game development for quite a few years now. I made a few prototypes here and there, had a few nearly finished games, and now I feel like I'm finally at a point where I can start my dream project. I've actually made a video before going over my background in more detail, so if you are interested in that, visit the link down below. So why do I feel like now is the time to start it? Recently, I graduated from uni and I've landed a pretty good job, so I'll have some expendable income to pay people to do the parts of game development which really just kill it for me. Stuff like music creation, art, things which I can do, but I would rather someone else do them. As well as this, I just feel like I'm at a point where I can actually start this project successfully. I've tried it a few times before. This has been something which I've planned for 5-6 years, but all of these attempts didn't go very well. I always got stuck or I got a little bit confused, but now I feel like I'm at a level where I can actually properly give it a go and hopefully be successful. So what is the game? The game's a mix between Dwarf Fortress, Mine Colonies, which is an old Minecraft mod, and a few other games which I've played throughout the years, which I absolutely adore. The idea is that you can build a massive dwarf city underground. You'll have tens of thousands of dwarves all inside of your city. You'll be defending from raids on your treasury and lots of other fun stuff. We'll get more into this as the series goes on. I don't want to spoil it all at the start. So yeah, the basic idea is this massive city builder, voxel based city builder underground, where you can build this massive Erebor, like Moria, like all of these awesome dwarf cities from fantasy. And the idea is that you can make these, make your own, fend against attacks, make massive forges, aqueducts, all these really fun things. So one thing, having to handle all of these agents and this destructible environment, performance is really important. So I've chosen Unity as my game engine because I'm the most familiar with it. There are other ones out there, but Unity is the one I'm best at. But we won't actually be using Unity for that much outside of rendering and maybe the time system. The rest is going to be handled completely in our own code, and we're only really going to be using Unity in a very small amount of ways. Another game which does this, for example, is RimWorld. It only really uses the rendering system, and for this reason it can have really good performance. So let's get into what this devlog covers. Firstly, the world system. So originally we had an idea that we were going to go regions, chunks, blocks, similar to other games such as Minecraft. This is how they do it, but this is just a bit too big. This is an interior game, and while this feels okay for most games, and I agree that it is, we're going to have very high vertical things. We have very deep mines, maybe things which don't necessarily really need to be rendered except from the chunks around it. So for this reason, we're just going with a chunk and then block system. We're just going to store all of these chunks inside of a dictionary and pull them out when we need to, and at one point only the chunks around the player area are going to be loaded, so we shouldn't really run into any memory issues. So firstly, we handed the block loading system. Now a goal of this game is to be highly moddable, which we will go into more detail on the next video, but we basically just made a system that can load a block off of a JSON, so it's completely customizable, pointing to different texture paths. And then just to make sure that this project, because as previously said, I've tried this project many times, but just to make sure that this project is clean and efficient, we're going to implement unit tests. So the first thing I did was just quickly implement my own framework in Unity. For unit tests, it weren't too complex. It just did some real basic tests. So once that was done, we could start on the actual world system. So basically it's made a basic chunk structure. The chunk would just contain XYZ amount of blocks, and then the world would contain XYZ amount of chunks. But one thing I wanted to be sure of is to program this in a way where each system is only really interacting with each other from one class. Normally you would implement this into like an interface, but for the sake of working in Unity, I'm not going to do that. So I made a class which was basically just the world system. So because of this, we're going to need some coordinate transformations. So I did a little bit of maths. There's a lot of edge cases as well, which basically you can plug in the world coordinates into this world system. It will automatically detect exactly what chunk this is required to, given that it is loaded currently in the space. And then it will calculate what exactly the block of that chunk is required. It's some pretty basic maths. It basically just divides it to see what chunk it has, and then does some small, you'll see them on the screen, it does some small transformations just to handle edge cases. It's a little bit messy, I'm going to clean it up, but it does the job. So with that done, which was basically just a simple data structure, we went on to the greedy meshing. Now this is what this video is really about, because this is something I've tried to implement so many times before with little to no luck. So what is greedy meshing? Greedy meshing attempts to make an optimized mesh by being greedy. Now greedy just means that it's going to perform in a certain way, which is greedy, right? It's going to try it and attempt something which it feels is right. It might not be, but it's going to try it because it's the best possible thing at that time. So because we have voxels, it's actually really important to ensure that we have good meshes. If we just make voxels as their normal blocks, we'll actually have to handle a lot of triangles in this situation. So for each block, you're going to have 6 sides. and each side is going to have 2 triangles. That's 12 triangles a block, which doesn't seem like a lot. If you're handling a 32 by 32 mesh, that's a lot of blocks. And if each block has that many triangles, you're going to run into performance issues very quickly. So the way this works is that it goes across the chunk and it goes up in runs. And when it goes up in runs, it just combines this mesh together until it finds either an error or a different block, at which point it stops the run, it builds that part of the mesh, and then it carries on to the next block. There's a very good blog post on this, which I took a lot of inspiration from. I'll link it down below. Big respect to the person who wrote this. It is very, very in-depth and easy to understand. So thank you so much for them. So with this implemented, we're finding really, really highly efficient and quickly generated meshes, which is awesome because we don't really want to be lagging whenever the player hits a block or deletes a block, so on and so forth. We're seeing meshes generated in about under 1 millisecond, which is great. And we're seeing the triangle count literally reduce by about 90%, which is amazing. But one issue of greedy meshing is it's very hard to UV map. UV mapping is basically just telling the mesh where to map on to the atlas that you've got. So firstly, I tried to build an atlas individually for every single chunk. This wasn't really practical. It was quite heavy on the CPU and it was actually quite high in memory. With the reason being, every single chunk would generate its own atlas, which would be stored in memory. So I figured probably a better way to do this is just to generate an atlas which every single mesh can map onto. This atlas will contain every single block up to 32 times in every direction. This is a little bit heavy on the memory. It takes about 200 kilobytes or so per block, but this is acceptable. 200 kilobytes a block isn't really that much, and realistically we're going to have maybe 200, 300 blocks, let's say 400 when you count in the different sides. So even then, that's really not that much memory to be holding. A lot of this will be on the GPU as well, so it matters even less. Obviously we don't want to use a lot of memory on the GPU, but I mean we're looking at maybe 40 to 50 megabytes. It's not really an issue, and it also will reduce the memory usage overall. Now another way of doing this was to make a shader which you would then pass the information into, and it would render the voxels at certain points depending on what this data was. I'm not very experienced in Unity shaders, so I didn't go with this option. It would be more efficient because it'd be purely on the GPU. For now, I think this is okay. If we ever run into performance issues, we will change this. The way I've coded it is that this is very changeable. The block atlas is generated in its own class, so we could easily just change the behavior in there and it will work all good. So I've really just ran over this very quickly. I could go into more detail, but this is supposed to be just a devlog updating you guys on the progress of the game. Currently, this game is not on Steam, but if you guys are watching in the future, if it is out on Steam, there'll be a wishlist link down below. Please wishlist it, it helps out immensely. Hopefully I can build this game into something we all love. And yeah, that's it for this video. The next steps are probably going to be making the player controller. It seems simple, but I think there's going to be a lot of heavy maths in figuring out exactly where the player is, what chunks to load, what blocks to break, what they're looking at, etc. And then after that, I want to implement the hierarchical, I don't know how to say this, okay, I've attempted this like 3 times. The hierarchical A star. However you say that, which will allow our agents to move across the world, basically tens of thousands of, well, maybe not that many, maybe not tens of thousands, but thousands of blocks with little to no lag, which would be awesome. So yeah, thanks for watching, guys. I really do appreciate it. If you like this, please subscribe. There's a Discord down below if you'd like to join it. I post more updates there than I do here. And yeah, thanks a lot. Subscribe, comment, all of that YouTube stuff. Woo. See you guys in the next one.